All right, so looking at number 1, it says the figure below, it says that PR and SR are tangent. So we have PR and SR, that means that they are tangent to the circle. Now remember, to be tangent, that means that if they are connecting at the radius, that means that those are right triangles. So they said that OT, so the distance from O to T is 11. Then it says that the distance from P to R is 60. What is the length of OR? All right, so if you see that OT is the length of the radius. So anything that is the radii in this particular problem, we can absolutely label that 11 and use that to our advantage. So I can see that this is 11. I can see that this is 11. But what I'm going to focus on is I'm going to actually go back and show you that we're going to look at this right triangle. And we're going to look at that right triangle because that right triangle we'll be able to do Pythagorean to help us find the length of O and R. All right, so if this right triangle, we're going to say, we'll call this C for the whole length. So they're saying that we have 11 squared plus 60 squared equals C squared. And of course, you can plug that into Desmos. So if we're substituting that, or we're plugging that in, we have 11 squared plus 60 squared, and we get 3,721 equals C squared. And then we're going to take the square root of that answer. And we get that the length that we were trying to find, the length of C, was 61. So that length that we were focusing on just a second ago, that length is from O to R, which is exactly what we're looking for. So my answer here is 61. All right, so number 2. Number 2 says, in the figure below, the larger circle, so the large circle has a radius of 6 centimeters. Then it says that my smaller circle has a radius of 2 centimeters. They want to know what is the approximate area. Okay, so what is the approximate area that we're going to be looking at in the shaded region? So if you remember, we talked about how to find the area of a sector. To find the area of a sector, it's theta divided by 360 times pi r squared. But they don't want the area of just any sector. They want the area of just this section left over right here. So what we need to focus on is we need to focus on finding the area of the big sector. So we're going to find the area of the big sector, and we're going to subtract the area of the small sector. And by doing that, that's going to leave me the leftover shaded area. All right, so I'm going to find the area of the big sector, and the angle measurement is going to be 30 regardless. So this angle right here that we're focusing on is going to be 30 regardless for the bigger one or the smaller one. So we're going to say 30 divided by 360 times pi, and the radius of the big one was 6, so 6 squared. So we're going to put that into Desmos, and we're going to calculate that, and I got approximately 9.42. Okay. Then we're going to find the area of the smaller one. So again, basically the same thing, still the same angle measurement, but instead of doing a radius of 6, we're going to do a radius of 2. Put that into Desmos, calculate that, you should get approximately 1.05. So at this point, we can now subtract the big area minus the small area. So we're going to say 9.42 minus 1.05, and we get 8.37, which is approximately 8.4. All right, so number 3, it says I have a rectangle, FGHI, and it has the diagonals F to H, and then it has a diagonal from G to I, and it intersects at E. So it says from I to E, that's going to be a 3x plus 4. And then it says from G to, or E to G, that this one right here is 5x minus 6. Now, because they're intersecting a rectangle, you should be able to determine or see that those two sides are equal to each other. So E to I and E to G, they're the same in length. They're congruent. So what I can do is I can set these equal. Now the question says that they want us to find the length of F to H. So F to H was actually what I highlighted in blue here. But the key is that if I can find the length of E to I and E to G, I can add those together and I know the length from F to H. So we're going to take these two values and we're going to set them equal to each other because we know that they're the same in length. And we're going to solve for x. Once we solve for x, we can easily find our value. Now, if you want, you can officially solve this and solve for x if you want to, or if you just want to kind of do the Desmos way. Remember, we split it in half. We said y equals 3x plus 4, and we have y equals 5x minus 6. So we solve that. We find that intersection, and we found that x equals 5. Now that we know that x equals 5, I can find the length of each piece. So I can say, okay, so 3 times 5 is 15 plus 4, that's 19. Well, the other one should be the same, E to G. So 5 times 5 is 25 minus 6 is also 19. So they are the same in length. So this is 19, this is 19. So that means the whole thing added together is 38. So if the whole thing is 38, that means that the other diagonal also has to be 38 because it is a rectangle. All right, so number 4, it says, William put the tip of his pencil on the outer edge of a graph of a unit circle. So if I think about a graph, it's saying that he put his tip of his pencil at 0 and -1. So here's 0, -1. Then it says he moved it an angle of 4 pi over 3 radians in a counterclockwise. So when we think about a clock, okay, so here's my clock. This is normally 12, 3, 6, and 9. This is clockwise going this way. So if we're going counterclockwise, we're going to go the opposite way. So starting from that point, it says he moved his pencil and he moved it by 4 pi over 3 radians. So I'm going to go ahead and convert that into degrees. And I'm going to convert that into degrees by multiplying it by 180 over pi. So once I simplify that, technically the pi's would cancel. So we have 4 times 180. Then we're going to divide that by 3. So we get 240 degrees. So we're saying that we're rotating this 240 degrees. So this is 90. So we're going the opposite direction, okay, of what a clock would do. So this is another 90. That's 180. And if I rotate even further, that's going to put me at 270. But I don't want to go to 270. So we're going to say somewhere in this range is going to be the rotation of 240 degrees. So the problem says, at what angle of the unit circle did his pencil stop? So when we think about standard position, so when we think about a circle, when we think about rotations, we normally start at 0 degrees here, but they didn't start 0 degrees there. They started a whole quadrant before that. So because we started a whole quadrant before that, all I would need to do is subtract a quadrant degrees. So 240 minus 90 degrees is going to give me a total of 150 degrees. So we just got to figure out which one of these matches 150 degrees. So we have 3 pi, or pi over 3, so we're going to multiply that by 180 over pi. And that's going to turn into 60 degrees, so that's not right. That's out. We're going to multiply that by 180 over pi. So we're going to say 5 times 180. And we're going to divide that by 6. So that's 900 divided by 6. So that's 150, which is what we're looking for. So that angle measurement right there is B. So again, the reason that this wound up doing why we subtracted the 90 degrees was because of the fact of where it started. They started here at 0, -1 when they should have started here. So in order to find the correct angle measurement of just this section right here, I would have to subtract that 180 or that 240 minus 90. All right, so looking at our next problem. So the length of a radius, they want to know the length of the radius, and they want to know which is represented. So this again is one of those where I would absolutely put this in Desmos. And when I'm looking at Desmos, we've talked previously, we've talked about how to adjust this. So we're going to turn off the minor grid lines, and we're going to turn this into a 1 and a 1. And that's going to put me with 1 step and 1 unit for each thing. All right, so I'm going to go back. I'm going to put in x squared plus y squared minus 4x minus 4y plus 4 equals 0. And when I put that in, that's going to give me my circle. So I can clearly see that my center looks like it's located at 2, 2. And since I'm located at 2, 2, they want to know what is the length of my radius. So remember, my radius goes from the center to the outside. So if we're going from the center to the outside, that means that we're going 2 units up, down, left, and right. So we put this in Desmos. We looked at it visually. All right, so for number 6, it says, I have a box with an open top. And that open top will be constructed from a rectangular piece of cardboard. Okay, so I have a box with an open section at the top. And we're going to make a top for it by using a piece of cardboard. Okay, so how is that going to work? Well, it tells me, it says that the piece of cardboard is 8 inches wide. So 8 inches wide. So this is the width. And this is the length. And it says that this one is 12 inches long. Now, in order to construct the box, what they're going to do is they're going to cut out equal squares out of each corner. And the reason they're going to cut it out is they can fold those pieces in and make a box, like a lid to a box. So they're going to cut those sections out, and they're going to be square-like. Now, each of those is labeled with an X. So this is X in length, that's X in length. We don't know what X is, but we know it's the length of it is the same on all sides because technically these should be squares. Mine kind of didn't turn out to be very square-like, but they should be squares. All right, so then it says they want to know what would be the domain of the entire function for the volume of the box. So if we're talking about the volume, so I'm looking at volume for a box is going to be length times width times height. They want to know what the domain would be. So remember, domain is my x values. Okay? So if we're looking at our domain, first thing I need to do is I need to figure out that my length and my width are going to be adjusted, because once I cut those squares out and I fold it, it's no longer going to be that long or that wide. So we're removing an x from the length and another x from the length. So what we need to do is we need to subtract 2x from the actual length. We're also going to be taking an x and an x away from the width, so we need to take away 2x over here. So our height, so when we fold it, our height is going to be the length of x. So our height is going to be the length of x just because of the fact that that is what we cut out. So if I set this up, my volume is going to be 12 minus 2x. My width is going to be 8 minus 2x. And my height is just going to be x. So they want to know what are the x values that this would work for. So at this point, we can put this into Desmos. And when I put this in Desmos, I'm going to be looking at the fact that my volume, we'll just call it Y. We're going to say 12 minus 2x, 8 minus 2x, and then x. Now, we got a kind of a big picture here, but here's what we're really going to be focusing on. So we're talking about volume. We're talking about length. We can only have a positive section because we're comparing length and volume with that, or that height with that x. We can't have a negative value. So if I kind of drew just a little sketch here, I'm only going to be focusing on quadrant 1. So quadrant 1, it goes up, then it goes back down, and it goes into the negative, and then it comes back up again. So we are not going to be looking at that. We're only going to be focusing on the positive section that is going to work for right here. Because once we go on the negative, it's no longer a real world situation. So we're going to be looking at where does it fall between in that positive section. Because the positive is the only one that works. So the original positive is our domain. So if we go back and we look in Desmos, I can see that it starts being positive at 0 and it stays positive until it reaches positive 4. So it starts at 0, it ends at 4, so my domain is 0 to 4. All right, number 7. So number 7 says I have a diameter of a circle. In my diameter of my circle, it says that I have 8 centimeters. So the first thing that I'm going to think about is the fact that if I have a diameter that's 8 centimeters, then I know I have a radius that is 4 centimeters. Okay, so we have a total of 8, but a radius of 4. Now, I also have a central angle. So remember, central angles, that is going to be an angle that forms. So let me highlight that in red. That's an angle that forms with the center. Okay, so it's going to form with that center, and it says that the angle of the circle intercepts the arc of 12 centimeters. So we know that we have an arc length of 12. So they want to know what is the radian measure of the angle. Because remember, there were two different formulas. Pi over 360 times 2 pi r, because we're talking about arc length now. Or we could do theta over 2 pi times 2 pi r for arc length, or for radians of the arc length, and use the radian formula. So I'm going to say that we are looking for theta. We'll call theta x, because that's going to be my angle measurement, over 2 pi. Times 2 pi times the radius, which is 4, equals my arc length, which is 12. So essentially we have here, I can go ahead and get rid of this 2 pi and this 2 pi, because once they get multiplied all together, those are going to cancel. So I have 4x equals 12. And then we're going to divide by 4. So my radian measure is x equals 3. All right, so number 8. Number 8 says a farmer wants to buy 90 to 100 acres of land. He is interested in a rectangular piece of land. So in my rectangular piece of land, it says that the land needs to be 1,500 yards in length, and then it says it's 300 yards wide that he's interested in. So it says it's being sold as one complete unit for $87,000. So it says if the farmer does not want to spend more than $900 an acre, then we need to figure out, does this land meet the requirements in this situation if he doesn't want to spend more than that. Now, the deal is that we have to convert acres and land and feet. So we've got to be able to convert some things here. Okay, so if you remember, we know that 3 feet is equal to 1 yard, but I need to be able to determine how much is actually being spent per acre if that's how much they're selling it for. Okay, so I'm going to come here. I'm going to go ahead and figure out the area However, if I'm looking at this, I know that my acres, they give me a unit here. They gave it to me in feet. So I want to go ahead and convert that over to make it easier. So we're going to say 1,500. We're going to say that times 3. And that's going to turn into 4,500 feet. And then the 300, we're going to say that's also times 3. And that's going to be 900 feet. So now to find the area, we're going to say length times width. So my area is 4,500 times 900. And once we multiply that together, you can multiply that in decimals. That's going to give you the area of that plot of land. So my area is going to be 4,050,000. Okay. So, and that's going to be square feet. So that's feet squared. Now, it tells us clearly that 1 acre is this many feet. So I need to figure out how many acres this land is. Once I know how many acres it is, I can divide it by the price. And once I divide it by the price, then I know if he's spending what he wants to spend on it. So we're going to divide this, and we're going to divide the feet by 43,560. And that's going to tell me how many acres it is. So we now can determine that my acres, acre-wise, is around 93 acres. So we have 93 acres on this plot. Now we need to figure out how much each acre by itself is. So we're going to say, okay, they're trying to sell it for 87,000. We're going to divide it by 93. And we can see that they're selling it for approximately $135 per acre. So if they're selling it for $135 per acre, the question is does that satisfy what he wants to spend? He doesn't want to spend more than $900. So the answer is no, the price that he is trying to find. So it says, yes, the land satisfies his needs. The price is low enough. The answer to that is that's not true because the price is too high. No, the price is low enough, but there's too much land. We wanted to go between 90 and 100. 90 and 100 is right. So the acreage is good. It's just the pricing is not. So no, the price is low enough. So the price is not low enough. So it says no, the amount of land is satisfied, but the price is too high. All right, so number 9. Number 9 says, what is the approximate length of the arc? So remember, length of an arc is arc length. It says if I have an angle that is 4 pi over 3 radians, so that's my angle measurement, and it tells me I have a radius of 6. So remember, with arc length, we have 2 options. We have theta over 360, and that's going to be times 2 pi r. So arc length, we have 2 formulas based off of what we're using. So we have theta over 360 times 2 pi r, or we have theta over 2 pi times 2 pi r, depending on degrees or radians. So this is obviously in radians. So to find the arc length, we're going to say 4 pi over 3. And that's going to be divided by 2 pi times 2 pi, and my radius is 6. And we can honestly and genuinely put all of this into decimals. You can simplify it if that is what you want to do. But at this point, I'm just going to go ahead and multiply it all out. I don't have to worry about making any mistakes. So I got approximately 25.1, making my answer C. All right, so the next one is a statistics question when it comes to kind of talking about a random sample. So it says, which method is most likely to produce a random sample of 5 students? So to be a random sample means that there can be nothing causing anything to be alike. So a random sample means that whatever they're sampling everything has an equal opportunity to be chosen. So whatever they're sampling, whatever it may be, anything that they are sampling from has an equal opportunity to be chosen. So we have to see out of these options, I put choosing. So everybody has an equal opportunity. So if I say that we're selecting 5 club members who have brown hair, well, that means that not everybody is equal here. Why is everybody not equal? So what happens to the people with blonde hair or people with red hair? Not everybody has equal opportunity. That is not random. We are actually putting a stipulation on that. So then B says that the 5 club members who have raised the most funds for the club. So if we're saying that they raised the most money for the clubs, that's still technically not random, because we're saying that there are people that are in that club. We don't know why these people were able to raise that much. So this is not considered random and a not equal opportunity. We're giving it to the people that did the most. Then C, it says selecting 5 club members from a hat containing their names. I would absolutely say this is random, because everybody has an equal opportunity to be picked from this hat. Everybody's name is put in. Everybody is blindly selected. The last one says that the 5 club members that arrive last. That's not random, because you're saying, okay, well, I can pick the people that raised the most money or pick the people that came last in the meeting. That's still not random. So the only way that it's random is because everybody in the hat had an opportunity to be chosen. All right, so number 11, it says I have a right triangle, and it says which expression would result in an irrational number. So the first thing I notice is that I have a y value, that's 2. I have an x value, that is 4, but I don't know the z value. Now, the irrational number that we're talking about, remember, irrational means that it's a decimal that continues on forever and doesn't stop. A number like pi, no pattern to it. So it can't be turned into a fraction. So the first thing I'm going to do is I need to figure out what c equals. So I'm going to do the Pythagorean theorem here, and I'm going to do the Pythagorean theorem because of the fact that it's a right triangle. So I have a squared plus b squared equals c squared. So we have 2 squared plus 4 squared equals c squared. And so we have 4 and 16, so we have 20, and this is z squared. So we now know that z equals the square root of 20. Now what's going to happen is I'm going to plug in everything I know, and I'm going to substitute it into Desmos now that I know each one, and see which one gives me an irrational number. So x is 4, so that would be 4 squared plus y is 2 squared. So again, that's rational, so that equals 20. That's a rational number. Same thing here. If I do 1/2 times x is 4 times the 2. So obviously 4 and 2 is 8. So that's going to give me 4. That is still going to be a rational number. All right, so then we add the x plus the y plus the z. So if we add a 4 plus a 2 and the square root of 20, anytime we're adding a square root, that is going to give me an irrational number. That is irrational because that decimal is going to keep going and it's not going to have a pattern. I could even try the last one, and because I'm squaring a square root, it's actually still going to work. So 4 squared minus z squared, so the square root of 20 squared. Whoops, let me put that on the outside. And you can see that that came out to be -4, which is rational. All right, so for number 12, it says the vertices of a triangle are 0, 0, 6, 6, and 9, 3. They want us to determine the volume, okay, in cubic units of a figure that is rotating around the line y equals x, and it's a triangle. Now, here's the issue that we have, and let's just go ahead and talk about it, is most students don't understand what this is asking because of the fact that they don't understand what they're saying when they say this rotation. So what I'm going to do is I'm going to go ahead and graph this on some graph paper. Do some units. The largest one we have is a 9. So I'm going to go ahead and divide this up. And it looks like we're really going to be focusing on that quadrant 1. So I'm just going to draw it so that I have enough room for everything in quadrant 1. All right, so the line y equals x, that's going to be the line that goes directly through that middle as best we can. And again, as best we can, you know, try to make it as exact as we possibly can. And then we're going to plot these points. So we have a point at 0, 0. All right, so we're going to graph that line y equals x as close as we possibly can. We know we're not going to probably be able to get it perfect, but within reason. So we're going to plot the point. We have 0, 0. Then we have 6, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And actually kind of it lands on that line. And then we have 9, 3. So we're going to go to 9 and then positive 3. So we have this right triangle, or I'm not even going to say right triangle. We have this triangle that's being drawn here over the line y equals x. So what's happening is we are going, the problem is saying that we're going to be doing a rotation. So here's what's happening is we're going to wind up rotating, and this bottom part, as we rotate, if you see that rotation is going to create a cone. So that rotation, that's the reason a lot of students don't see it, is because they don't understand that that rotation is creating a cone. And the volume of a cone is 1/3 the base times the height. And the base itself is a circle. So my base, we need to find the radius in order to figure that out. All right, so how are we going to find this? Well, we have a right triangle in this problem that we can use to calculate our values. And what do I mean by that? Well, I can count with this triangle. I can have a right triangle here. I can do whatever I need to do to find the radius. So right here is my radius, okay? So this is the distance that we're looking at. Now for just a second, I'm going to kind of erase that so we can see that whole thing. So in order to find that radius of that rotation, we're going to have to do Pythagorean theorem, and we're going to have to do the Pythagorean theorem for the radius, and then we're going to have to do the Pythagorean theorem for the height of the actual triangle. Okay, so again, remember we're doing a rotation here. I know that is kind of hard to see, but that's the rotation that we're going to be looking at. But we've got to find the radius and the other pieces. So this is going to be 3 and 3. So to find the radius, we're going to say, okay, we have 3 squared plus 3 squared equals r squared. So that's going to be 9 plus 9 is r squared. So we now have 18. So we know that our radius is the square root of 18. So we got the radius. Now that we have the radius, we can work on finding the height. So the height is actually going to be this distance here. So the height is, remember, from the top to the base. Okay? So I don't really care how you find that length, but you're going to have to do the Pythagorean theorem again. You're going to have to count some units, and you're going to have to calculate. So what I would do is I would, once again, I'd pick some point, I'd make a right triangle. Okay, so this is going to be 1, 2, 3, 4, 5, 6 units. 1, 2, 3, 4, 5, 6 units. And so at that point, we're going to say 6 squared plus 6 squared equals r squared. So we got 36 and 36 is going to be 72. And we're actually not going to use r, we're going to use h because we're looking for the height. So now we know the height is going to be the square root of 72. And now I should be able to plug in everything I know. So I know that my base is 1/3. Is 1/3 times the base, which is pi. My radius, we now have 18 squared, times my height, which we know is the square root of 72. Now, I can put all of that in. I can calculate that, and I'm going to get the volume is approximately 159.9, give or take. So what I need to do is I need to see which one of these matches up so I don't have to necessarily figure or have to go through the process of simplifying later. I'm going to just go through Desmos and figure out which one matches the square root, because they obviously didn't calculate it and simplify it. Or they did simplify it and we didn't simplify it. So we got 36 pi, then the square root of 2. And we find that that is the correct answer. So my correct answer is C. All right, so then we come to number 13. So number 13 is one of those that we really didn't get to talk about the properties within a triangle like this, but I'm hoping that you can visually see it. And all the times that I've ever done this, it always is set up in such a way that you should be able to see it. So I have this triangle, and it says the measure of H and J, or G and H, excuse me. So the measure of this is going to be x plus 3. Then it says the measure of PG is 4x plus 1. And then finally, it says that the measure of G to J is 2x minus 1. So when I look at this, they're asking us to find the measurement of P to G. So we are trying to find the measurement from P to G, but I really have to be able to find what X is first. So when I look at this, I should be able to clearly see that this one and this one are the same length. Okay? So if they are the same length, so if H or G to H is equal to G to J, I should be able to set those up and say x plus 3 is equal to 2x minus 1. You can solve that in Desmos, or you can go ahead and solve it here. So I'm going to add that 1 over, so I get x plus 4 equals 2x, subtract x, and we get 4 equals x. So we now know that x is equal to 4. But they want us to find P to G, so the purple. So P to G is 4x plus 1. So we're going to say 4 times 4 is 16 plus 1 gives me a total of 17. Okay. All right. So then we come to number 14. The figure below shows a circle within a circle, a concentric circle, so two in between each other. It says that the chord XY is tangent to the smaller. So if it's tangent, that means it's hitting it right there at that point. So remember, that is very key, is tangent means it's hitting it at one point, which then means that the radius, remember the tangent is always going to be perpendicular to the radius. So that's going to be super important. It says the radius of the larger circle is 15 centimeters and the radius of the smaller circle is 12. So the radius of the smaller one is 12. But then the radius of the bigger one, which is the whole thing, is 15. They want to know what is the length of the chord. The other thing that we talked about is if I have a chord, then I should be able to determine that this side is equal to this side. If I can find one of them, then I know both of them because it's a chord and it's a tangent line to that chord and it's perpendicular. So here's what I see. I did, and I found the radius of the smaller circle, but that larger circle, I can draw a radius anywhere. So I can draw the radius to the outside of the larger circle and make a right triangle. And I now know that this length is 15. So I can do Pythagorean theorem, and I can set that up to find that missing section. So we're going to find the first one, and then we know that it's going to equal to each other. So I'm going to say 12 squared. We don't know what that other one side is, so we'll leave that as b squared, and we'll say that equals 15 squared. Okay, so 12 squared is 144 plus b squared, and that equals 225. So we're going to subtract that over. B squared is equal to 81. Take the square root. B is equal to 9. So I now know that the length half of it is 9, so that means the other half is 9. So if we add those two together, the length of my chord is 9 plus 9, which is 18. So my suggestion when you're doing problems like this is always try to find a right triangle. Right triangles are really your best friend in these types of situations. All right, so number 15. Number 15 said David plans to cover his floor of his room with new material. The floor is an isosceles trapezoid. So isosceles trapezoid means that I have a trapezoid, but the two sides of the trapezoid are equal to each other. Okay? So it's kind of hard for me to draw that, but they should be the same. So that means that this side is the same as this side. Now, it says the bases are 16, so the smaller length is going to be 16, the larger one is 26. And the sides are 13, so this is 13 and 13. Each piece of new material has an area 2.5 feet. So it says, assuming that the pieces of new material are cut as needed, how many pieces does he need? So I need to find the area of the trapezoid. Now, the area of trapezoid is 1/2 the base times the height. However, I got two bases. So when I do my two bases, I got to add those together. So remember so trapezoids have two bases. So it's still going to be 1/2 base times height, but the bases are two of them, so we got to add them together. Now, the height, that's going to be the tricky part. My height is the perpendicular height. It's going to be from base to base. So in order to find that, I'm going to need to do Pythagorean theorem. But in order to do Pythagorean theorem, we got to figure out what this leftover section is. So what I'm going to do is I'm going to do some skills here where I'm going to say, okay, I know from here to here, because this is a height as well, right? We know that that's 16. So if I subtract 26 minus 16, I'm left over with 10. Well, that means this is the same and this is the same. So if I divide 10 divided by 2, that's going to give me 5. So I now know that's 5. So now all I need to do is do Pythagorean theorem to find the height, and I can plug in what I know. All right. So I'm looking at a squared plus b squared equals c squared. So my a we'll say is 5. My b is h because that's the height that we're trying to find. And 13 is, and the hypotenuse is 13 squared. So once we solve that, we got 13 squared minus 5 squared. And that's going to give me 144. And if we take the square root of 144, we now know the height is equal to 12. So I can find the area of my trapezoid. So I now know that this is going to be 1/2 the height, which is 12. Technically, half of 12 is 6. And then we're going to add our base of 16 and 26. All right, so I can put that all into Desmos. All right, so if I multiply that together, if I do 0.5 times 12, that means that I'm going to have 252. However, each piece is going to be cut in a square foot of 2.5. So if I divide 252 by 2.5, that means that I'm going to need 101 pieces. So my answer is A. Now, number 16 is definitely a statistics question, but if you read it, all you have to do is plug in what it's given to you. So they give us the formula. It says a high school randomly selected 75 out of 200 seniors to take a sample college entrance exam. The mean grade, so the mean average of the senior selector is 2.85, and the standard deviation was 0.4. So it says click all the statements that are true. So here's the deal. They want us to figure out the margin of error. So the margin of error means the more people I'm able to sample, the lower the margin of error is. If I pick 5 people, my error, or what I'm actually calculating, may not be as accurate as if I pick 100 people. So the more people, the more accurate that it is. So the margin of error tells me how accurate my prediction is. So the margin of error tells me how accurate your values are. All right, so they gave us the formula. They told me the margin of error is 2 times S over the square root of N. Now, S stands for the standard deviation, N stands for the sample size. All you have to do is plug in what you know. So we're going to do 2 times. It said the standard deviation was 0.4. And we're going to divide that by the square root of the sample size. The sample size was 75. All right, so we're going to multiply that together. So we have 2 times, and we're going to say the square root of 0.4 and then the square root of 75. So we get approximately 0.092. So that is my margin of error. So that's the first thing that I would select as being correct. My margin of error based off of what I got is 0.092. Now, it says in the next two statements, the margin of error would decrease if the sample size changed to 120. So if we change the sample size and go up, they're saying that the margin of error would decrease. The margin of error would increase if we go to 125. Well, let's try it out. If I go to 125, my margin of error, so if I change that and I test it and I change it to 125, then it's going to be approximately 0.07. So my margin of error, so the error that I could have, so I'm more accurate with more people. So the margin of error did in fact decrease as I increase the sample size. So the margin of error, so how much you can get wrong, is going to go down as you sample more people. All right, so they just want to know what is the value for x in the rectangle. I hope we all can agree in this rectangle we're talking about both angles that are 90 degrees. So we're going to set this up and we're going to say 4x minus 12 plus x plus 2 equals 90 degrees. You can put this in Desmos and solve this doing two separate pieces, or if you want to just go ahead and solve it by hand, it shouldn't take too long. So we got 5x minus 10 equals 90. Subtract 10, so 5x equals 100. Divide by 5, and we have x equals 20. Now, if they did ask you for the angles, obviously I could say 4 times 20 minus 12. So 4 times 20 is 80. Minus 12 is going to give me 68. And then I could do the other one, which is 20 plus 2, which is 22, which I can agree that they both add up to equal 90. So this one says, what are the values for x and y? So if I'm looking at this one, I should be able to see that this angle, so I'm going to try to highlight this the best I can. So this angle right here that is being made is the same as this angle. So this angle right here is the same as this angle. Okay, so they're equal to each other. But those have an x and a y. So when I'm looking at this, I've got to figure out what x is first. So to figure out what x is, I should be able to see that A to B and D to C, they are equal to each other. So we're going to say AB is equal to DC. So we're going to set up an equation. We're going to say 6x or 3x plus 3 equals 6x minus 18. So we can solve that. Well, we got, if I move that over, I got negative 3x, and we're going to subtract the 3 over. That's going to give me negative 19. So we're just going to move our stuff over, or you can solve it in Desmos, completely up to you. And I got negative 19, and that is not right. So that's going to be negative 21. Divide by negative 3, so x equals 7. So why would I need that? Well, I need that because now I know the angle BAC is equal to angle DC and A. So BAC, so B to A to C, B to A to C is 7y. So that's 7y minus 3. Well, I didn't find what y is, but I did find the DCA, which is 2x plus 4. So I know that my x is 7, so we're going to say 2 times 7 plus 4. And we should get 14 plus 4 is 18. And I can finish solving for y now. So I can add the 3 over, so 7y equals 21, and y equals 3. All right, for number 19, this problem says that you have a triangle XYZ, and A is the centroid. So remember, the centroid has medians, and if I have a median, that means that it goes from the middle to the angle. So in this situation, we know that if I have a median, so this section right here, this line is, if this is, let's say this is n, then the other section of it is double that, which is 2n. So basically, in this particular example, they say that they want dz. So they tell us that dz is approximately, or is 12. So I'm going to set up an equation. So let's say that this is n and this is 2n. So I know that n plus 2n equals 12. Well, if I combine like terms, that gives me 3n equals 12. So therefore, n equals 4. Well, they want us to find the distance from D to A. So D to A, or A to D, is going to be 4. And then the distance from Z to A, or A to Z, is going to be 2 times that, which is going to be 8. All right, so for number 20 says that TR is the diameter of circle O, and it has a length of 16. So for this distance right here, we know that T to R is the diameter. Now, they want to know what is the approximate area of the sector that is bound by POR. So we're looking for the angle POR. So I'm looking for P, O, and R. So they want to find this arc, this area right here. So with that being said, I see that my angles are in degrees. So we're going to use the degree formula. So remember, that's theta divided by 360 times pi r squared. So we're doing pi r squared because we're doing area. So if I add up my two angles that create that area of that angle, we're looking at 125. So this is going to be 125 over 360 times pi r, not r. If we know this is 16, then that's going to have a radius of 8. So that's going to be 8 squared. All right, so let's pull in Desmos so we can put that in. So we have 125 divided by 360 times, and we're going to do pi times 8 squared. And I got approximately 69.8. So 69.8 would round up to 70, making the correct answer A. All right, so let's look. So you should have already done 21. 21 you would do in Desmos. You would look for your center, and if you plug that into Desmos and you check, the correct answer here is B. So if we check that, we can see that we have y minus 3 equals 25. If you like doing it with the minor arcs and 1 and 1, you can do that as well. Because my iPad is zoomed out, it's not going to actually, there we go. So this one does have a center at -2, 3. And I do have a radius of 5 units. So the correct answer here is B. All right, for 22, it says Jessica created a model of the ice cream cone by combining the shapes of a cone and a hemisphere, which is half a circle or half of a sphere. So, using the dimensions of the model, what is the volume of this? So, there's two things that we're going to have to do here. We're going to have the volume of a cone, and we're going to have to find the volume of the sphere, and then we're going to take the volume of the sphere and we're going to divide that in half because we only have half of one. So remember, the volume of a cone is 1/3 my base times my height. The sphere is 4/3 pi r cubed. So the first thing I'm going to do is I'm going to find the area of my base here, which my base is a circle. So I can find that I'm going to find the area of a circle, which is pi r squared. So my radius is 3, so I have pi 3 squared. And for right now, I'm just going to leave it in terms of pi because I see my answer choices are in terms of pi. So this is 9 pi. Now I'm going to find the actual volume, which is 4/3 times 9 pi times my height, and my height here is 10. So I'm only going to multiply my numbers in this particular problem. So we have 1/3, 9, and 10. So I can just plug that into Desmos. So I have 1/3 times 9 times 10. And that gives me a volume of 30 pi. All right, now I'm going to do the volume of my sphere. So I have 4/3. And that's going to be pi, and my radius is still going to be 3, but that's going to be cubed. So again, I'm going to do 4/3 and the 3's cubed. And that's going to give me 36. And I have 36 pi here. Now, I need to divide that in half, because if I divide it in half, that gives me half of the sphere. And I only want half of the spheres because that's all I have for the ice cream cone. I don't have a whole sphere. So when I divide that, my volume is going to be 18 pi. And then, of course, I'm going to add those two together to make the whole thing. So that's going to give me 30 pi plus 18 pi is going to be 48 pi. So my correct answer is A. All right, so for 23, I have a cylindrical tank that holds 289,000 gallons of water, and it is 23 feet deep. What is the approximate diameter of the tank? All right, so first thing I need to I like to draw my little cylinder, and I know that the height, or because it's 23 feet deep, that's 23 feet. Now, one thing we need to pay attention to is the fact that it told us that 1 cubic foot is 7.5 gallons. So what we're going to do is we're going to find the volume of the actual tank. And once we find that we can find the volume by taking the gallons of water. So we know that the gallons of water here are 289,000 gallons. So if I divide that by 7.5 gallons, that's going to give me 1 cubic foot. And 1 cubic foot is 1 cubic foot of volume. So I'm going to find the volume by saying the 289,000, and I'm going to divide that by 7.5. And in doing that, that's going to give me the volume. And I need to find the volume so that I can find the diameter. And I can find the diameter by finding the radius. So this is going to be approximately 38,533.3. So we're going to take our volume formula. So remember, the volume for a cylinder is base times height. Well, I have a circle as my base. So my base here is going to be pi r squared. So I know that my volume, so I'm going to kind of color code here. I know my volume is going to go here, and I know that my height, so my height in this particular problem, let me get another color. So my height is 23, that's going to go here. And what I'm going to do is I'm going to plug that all in, and I'm going to solve for R. So I'm going to solve for R, and then once I solve for R, I can find my diameter. So I have 38,533.3, and that's going to equal pi r squared times my height, which is 23. Now, remember, we're trying to solve for the actual radius, so everything here that's not with the radius, I can go ahead and divide over. So I can divide 23 and pi on both sides. And by doing that, that's going to give me r squared left. So if I divide that and I do 38,533.3 and divide it by 23 pi, I get 533 we'll say 3, and that equals r squared. Now remember, if we want to solve for r, we're going to take the square root. So I'm going to take the square root of 533.3, and I get that r is approximately 23.1. But the question doesn't want just r. The question wants the diameter. It doesn't want the radius. So I'm going to multiply that by 2. So if we multiply that by 2, we got 46.2, so approximately 46. All right, so for 24, that should have already been done. So for 24, you would have done this in Desmos, and you would have matched the graphs. And you should have got that the answer was A. All right, so for number 25, so it says, suppose we have this polynomial. Now, the key to this polynomial is we're missing the constant, which they labeled as K. It says the remainder of the division, if we divide it by x plus 1, is negative 8. What is the remainder of the division if they divide it by x minus 1? So this is a two-step. The first thing we got to do is figure out what K is. Once we can figure out K, then we divide it by this polynomial. So what I'm going to do is I'm going to set up synthetic division. And I'm going to set up synthetic division so that I can use what they've given me. So I have positive 1, and we're going to use negative 1 because it's always the opposite. And we know the remainder is 8, so I don't need any placeholders. So I'm going to pull my constants, and I'm going to put the K there. And I know my remainder is negative 8. So I'm going to go through, and I'm going to do negative 1 times 1 is going to be negative 1. Add that, get negative 3. Negative 1 times negative 3 is positive 3. That's going to give me 16. Negative 1 plus 16, or negative 1 times 16 is negative 16. So the question is what does K have to equal in order to add negative 16 and get negative 8? Well, K would have to equal 8. So now that we know that, we found K, we can do synthetic division again, but now we're going to divide it by x minus 1. So if I divide it by x minus 1, we're going to do the opposite, so it's positive 1. And we're going to do 1, negative 2, 13, but now we know K is positive 8. So they want the remainder. So we're going to pull 1 down, multiply that by 1, add that, get negative 1. 1 times negative 1 is negative 1, add that, get 12. 1 times 12 is 12, add those, and you get a remainder of 20. All right, so number 26, you should have already gotten this answer as well based off of what I asked you to do in class. The answer was D. So remember, you take the left side, you do y equals that. You do the right side, do y equals that, and you find the intersection. And you can do that with any equation. If it's an equation and it has an equal sign, you can do that with any problem. All right, number 27. It says Samantha invested $10,000 in 2 different financial plans in 2013. The predicted value of the plan is modeled below. So we have Plan M. Plan M has a rate of 7.5% compounded continuously. So if you remember, compounded continuously is y equals PERT. So I know this is y equals, my initial value is 10,000. E, we're going to change this to 0.075, and T. Now, they give you that plan N, so we have plan N as well. It is given to you by a polynomial, and X is the number of years after 2013. So, they want to know, when is plan N greater than the predicted value of plan M? So we got to figure out when is that greater. So I recommend using Desmos here and look at the graph. So you would put in both equations. So we have 10,000 e raised to 0.075x. Then we have y equals, and then we're going to put in the polynomial given. Now, here's the deal. So if we're looking at this situation, if you notice that the initial value is 10,000, so you would need to adjust your graph. So we would need to go to the y-axis, and if we're looking at 10,000, let's give ourselves a little wiggle room and do 15,000. So if I do 10,000, here's what you're going to barely just kind of see it. Now, if you want to do that and then adjust it, you can definitely do that. So the question is when was plan N greater than plan N? So remember, plan N for ours is in black. So when is it greater? So along the graph here, so purple right here in this area is still above it. So that's not greater. So we're going to keep going. We're trying to look for when the purple goes below. So the purple goes below after 28 years. So that's a key thing. So it starts at 28 years. It's still above, still above, still above, still above, still above, still above. So our plan N is still above in this situation. So it stays above it. So the question is 28 years, when did it actually go above it? Well, if we started in 2013, then we're going to add 28 years to that. Okay, so 8 plus 3, that's going to give me 11, and that's going to be 4. So 2041. Well, obviously, give or take a year because it's approximate. So we would say it started in 2042. So in 2042, that's when it began. Now, this says that it stopped in 2073. So I'm going to just kind of check that out, and I'm going to subtract the original year. So we're looking at 60. So if we're looking at 60 years, so if I that would be like me zooming completely out and going to look at, we're getting close over here. So 60 years is this line. If you look down at the very bottom, you can see 60. And we're getting close. We're not, there it is. So 60 years later, that's exactly what the problem said. So it's just a matter of you manipulating the graph a little bit. All right, so for number 28 says the system of equation is shown below. What is the distance? So distance means that we're going to subtract our two values. Or we may have to find the distance using the Pythagorean theorem. So those are the two options that we can go with. It just kind of depends on what the problem looks like. Of the 2 points of intersection. Now, I'm probably going to guess that we're going to have to do Pythagorean theorem, because if we're looking at the intersections are going to be diagonal from each other. So x minus 3. And then we have y equals 1/2 x. All right, so we have our first point at 1, 2, and our second point is at 6, 3. So I'm just going to kind of draw a general graph here. So we have 1, 2 is our first point of intersection, and then we have 6 and 3. So they want to know what is the distance between those two. So yes, we are going to have to do Pythagorean theorem here. So if I do Pythagorean theorem, remember you can make your right triangle your L. And when you do that, that's going to help you find your A and your B value. So that's going to be a unit of 1. All right, so I just realized that I graphed this wrong because the first point was at 2 and 1. So that's 2, 1. And then the other point is at 6, 3. So we want to find the distance here. All right, so we're going to redraw that and do our L shape and get our right triangle. So we have a distance of 2 and a distance of 4. So we're doing a Pythagorean theorem for 2 and 4. So we're going to do 2 squared plus 4 squared, and that's going to help us find c squared. So 2 squared is 4 plus 4 squared is 16, so that's 20. So c squared, we take the square root, and my distance is the square root of 20. All right, number 29 says Fred drives an average of 15,000 miles per year, and his car gets 20 miles per gallon of gas. The average cost is $3.25 per gallon. He buys a new car. In his new car, Fred continues to drive an average of 15,000 per year, and the average cost of gasoline remains the same. Approximately how many more miles per gallon does the new car get if Fred has a savings of $650? So the first thing we need to do is we need to analyze the old car. So if we analyze the old car, we know that he drives 15,000 miles per year. And out of those 15,000 miles, he gets an average of 20 miles per gallon. So we're trying to find the gallons that he uses per year. So if I divide that, so if I do 15,000 divided by 20, that's going to give me 750 gallons that he uses per year. So if he uses 750 gallons per year, then we want to know how much he's actually spending. So he's spending, if I multiply it by the price per gallon, he's getting, so we're going to multiply it by 3.25. So he's spending around $2,437.50 per year. Now, the key to this problem is it says that he has a savings of $650 per year. So now we're going to talk about the new car. So with the new car, we're going to subtract that $650, and we're going to figure out how much he's actually spending per year. And he's spending with the new car $1,787.50. And now we're going to work backwards. So we're going to divide the $17,807.50. We're going to divide that by 325. And if we divide that, that's going to give me how many gallons he's using in his new car. So he's using 550 gallons. Well, if he's using 550 gallons, then we need to figure out how many miles he's actually, how many miles per gallon he's getting. All right, so we know he's getting 550 gallons in his new car. That's how many gallons he's using per year. So he's still going the same amount. So we know he's going 5,000 miles. So we're going to divide that by the gallons, and that's going to give me how many miles per gallon he's able to get. So we're going to do 15,000 divided by 550, and we know he's getting 27.3 miles per gallon. Well, the question is, how many more miles per gallon does he get in his new car? Well, he gets 27.3 in his new car minus the original 20, so he's able to get about 7.3 more miles per gallon. All right, number 30. So a student wants to determine the most liked professor in her college. Which type of study would be the most practical to obtain this information? So if I do a simulation means you model something and you see it in real life and you mimic that. Well, if you're trying to figure out who's most liked, you can't really do a simulation, so that's out. An experiment means you actually experiment whether how can you determine if they're liked or not by doing an experiment, because everything could potentially be different in that experiment. So then we have a survey. and we have an observation. Well, you could observe the students with the professor and see who likes the professor, but who's to say that if you pick a class, that one class likes the professor over another? So a survey is the most practical because you can survey a multitude of people, and on top of that, you can get a variety of people. All right, number 31. It says a principal wants to survey 150 students to determine which electives to offer during the next school year. There are 1,800 students in the school system, or in the school. Which procedure could the principal use to select a sample using a systematic random sample? So random sample means that anybody has the same probability of being picked. So we still want that same thing. We still want the same probability of people being picked, but a systematic means that you have some type of procedure to pick them. So it's not just I'm going to put every 100,800 students in a hat and pull their names. This is more systematic where it's a little bit easier. So the first one says obtain a list of all students. Start with the 8th student and then select every 12th student until 150 have been selected. Then the next one says select the first 150 students who enter the school. Choose the 5th student to come into the cafeteria and then select every 3rd student who comes into the cafeteria until 150 have been chosen. Place students' names on a slip of paper and select 150 slips. So D is definitely random, but I would not consider that systematic. Systematic means that there is an actual system, there is a procedure. So if you just put slips of paper in there, that's not going to be systematic. So D's out. Now, for C, choose the 5th student to come into every 5th student to come in the cafeteria, and then select every 3rd student who comes in the cafeteria until 150 have been selected. Well, that is systematic where you would select every 3rd. However, it is not at random because you're only choosing people that go to the cafeteria. Not everybody goes to the cafeteria, so not everybody in the school as a student has the opportunity to be selected. So that's not random. B says select the first 150 students who enter the school. So again, that's not systematic, and I wouldn't consider that necessarily. It kind of is random, but everybody doesn't have the likelihood of being selected because you're talking about the first 150 students in the school that may be a select pocket of kids versus others. So A says select a list of all students. So there's the key. All students means that everybody has the same likelihood of being selected. So we select the 8th student and then select every 12th student until 150 have been selected. So not only is that random, but it's systematic. So the answer is A. So for number 32, you should have already done this problem. The answer was D. You can look at this in Desmos, or you can look at or just know your rules. So this one says we're going down 2, so we're going to subtract 2 from the back so that we can get rid of A and C. And then we're going to go to the right 3. So remember, when you're in the function, it's the opposite. So instead of being plus, it's going to be minus. If you decide to look at it in Desmos, you can look at the original. So we can look at x to the 3rd. Y equals x to the 3rd. And then you could check every answer. So if I do the first one, I would have x plus 3 cubed, and then we're going to do plus 2. So if I'm looking at, let me move this over. If I'm looking at my pieces, I can see I start at 0, 0, and I'm going to, so this point right here is at negative 3 and 2. So this one went to the left and up 2. So that's not going to work. So you could check every single one until you see that D goes to down 2 and right 3. All right, so our next question, again, we already talked about that one. The answer to that one was C. So to be an inverse, remember, it's a reflection over the line y equals x, and you would see that if you plug that original one in, if we have y equals 1.5 raised to x plus 4, and because it's an inverse, it's symmetric over that line. And then if we put this one in, So we have log of x, and then we're going to subtract 4. And then on the, oops, that is not correct. That's on the outside of the parentheses, so let's redo that. And then we have log of 1.5. You can see that that is symmetric. You can even check a point if you want to. You could check the 0, 5 and 5, 0 because they should flip with each other. All right, so for number 34, it says the volume of a rectangular prism. So we've discussed rectangular prisms before. It's completely up to you how you want to draw it, but what I normally do is I normally just draw 2 of them. I duplicate, line them up, but I like to have visuals no matter how many times I've seen a prism. It just helps me to visualize what it's actually talking about. So it says I have a rectangular prism, and it tells me that it is represented, the volume is represented by x cubed minus 2x squared minus 20x minus 24. Then it tells me that the length is this and that the height and the width are equal. They want to know what the width is. So first thing I'm going to say is I know the volume, and I know the volume of a prism is big B times H, or technically length times width times height. So if I'm able to do this, I just need to divide my volume by the length, and then I'm left with the width, the height and the width. So I'm going to do synthetic division here. I'm going to make this as easy as possible, and I'm going to divide this out, and I'm going to say, okay, I have 6, and then I have 1, -2, -20, and -24. So I'm going to bring this down. So I have 1 here, so that's going to be 6. Add that, that's going to give me 4. That's going to give me 10. Add that. Oh, that is not correct. 6 times 4 is going to give me 24, so that's going to be 4 again. 6 times 4 is 24, which gives me a remainder of 0, which it should, just because we know that is one piece that is exactly correct. So I have x squared plus 4x plus 4. Now, it does say that the height and the width are equal, so I need to break this down even further to figure out what they are. And we're going to do that by factoring. So when I look at this, I can say, okay, what are 2 numbers that multiply to give me 4? But then those same 2 numbers are going to add to give me 4. And of course, that's going to be 2 and 2. So if I break this down, this is going to be x plus 2, x plus 2. So we now know that my length was originally x minus 6. We know my height was x plus 2. And we know my width was x plus 2. They asked for the width, so the answer is A. All right, for number 35, we have a piecewise function. They want us to find f of -3, 2 times f of -1, and then minus f of 4. So for the first one, I have f of -3. Well, f of -3 is equal here, so we're going to be plugging it into this one because it's equal. All right, so I'm going to plug that into Desmos, and I get -3. And I'm going to square that, and we're going to do 2 plus -3. And this gives me -15. All right, for the next one, I have -1. Well, -1 falls in between that area, so we're going to plug it into that one. So we have 2 times 1/3. And we're going to raise that to 2 times -1. And we get 18. Now, this needs to be 2 times 18, so that's going to be 36. And then for the last one, we have +4. Well, this one is equal to 4, so we're going to plug it into that one. Now, it may not always happen where you plug it into every one. You need to check the domain that's given. So we have 2 times 4 minus 5. And then we have 4 minus 7. And that's going to give me minus negative 1. And then I just figure out the whole thing. So we have negative 15 plus 36 minus negative 1. And I got 22. All right, for number 36, so it says which function goes to positive infinity most quickly as x increases? So most quickly means which one is the steepest. So which one is going to have the steepest change on the right side? Why the right side? Because this when x is increases. So for these, I'm going to want to put these into Desmos, and I'm going to compare all of my graphs. So I have log of x. I have e, and that's being raised to x minus 9 minus 3. Then I have y equals x squared plus 5x plus 6. And the last one. So 3x to the 5th power plus 4x to the 3rd minus 11x minus 6. So there's a lot going on here. So let's kind of look at our graphs. So I can see that the black one definitely is not going to be, so the black one is the E one. Why is that not going to work? Because all of these other ones on the left are going up much quicker than this black one on the right. So we're getting to the Y values a lot quicker with the other ones. So I can also see in the red one's taking a lot longer to get there than the blue and the purple. So the red was the polynomial. So then last, so we're basically comparing the blue and the purple. So the purple is the logarithm. So obviously the logarithm is very close to that line. So it's going up y much more quickly than the blue is. So the answer to this one is A, because the purple one is the steepest out of all of them on the left side or on the right side. All right, so for number 37, you should have already done this one. Remember, we have an equation, so we're going to set them equal to y, and you should have got your answer is A. So if we look at those, I have y equals 9 raised to, and there we have negative 3x plus 2, and then y equals 48. So in this situation, we're definitely going to have to get up to 48 and then zoom in. You can zoom in however you feel like you need to do it, but click it, and it's always the x value. Same thing with this solution. I would have set this equal to y, this equal to y. Now, the key to this one is it would have given you a decimal, and you would have had to check all of your answer choices to figure out that your x value was 2.8, and your answer should have been D. All right, for 39, we already you already should have done 39. So for 39, you would have put this into Desmos, and you would have matched your graph. The only thing you've got to be careful here is when you put this in Desmos, it's not going to be formatted exactly the same way. So we have x plus 7, and then we have x squared plus 4x minus 21. And then divide that. You see how it does a division of the whole thing again, and hit the division again so you can get that whole fraction divided by. Then x squared plus 8x plus 15. And there's my graph, and the correct answer for this one was A. So once you checked your answers here, when you plug these in, you're going to see which one matches, and I can see that my blue overtook my red, so that's the reason it matches. So the next one says, which function does not have a set of all real numbers in the domain? So all real numbers means negative infinity to infinity. Now, when I look at this, I'm going to be looking at which ones have either a denominator, because remember, denominators cannot be equal to 0, or a square root. So the one that has a denominator is B. Those are the only two things that can happen to cause it to not have a domain of all real numbers. All right, so for number 41, again, you're going to put that in Desmos and you're going to match the graph. The only thing I will say is be careful. If you look, these have negative exponents. That's okay. You just plug them in the same way you would any other exponent. And your correct answer would have been D. Now, number 43 we've done before, but I did want to hit it real quick just to make sure that we remembered how to do it, because this is a type of problem I cannot match in Desmos unless I plan on guessing and checking at all of the pieces. But basically, where it's an addition problem, and in order to do addition, we have to have a common denominator. So right now, I need my denominator to have an LCD of x plus 4 times 7x minus 2. Okay, so that means that on this side, we're going to multiply this side by 7x plus, that should be minus 2 over 7x minus 2. And then on this side, we're going to multiply this side by 4x plus 3 over 4x plus 3. All right, so first thing I need to do is multiply that. If you need to use your box method to multiply, please do. If you don't, then no worries. Just multiply it like you normally would. So in this situation, I'm going to get 21x squared, negative 6x. This is going to be negative 35x and positive 10. And then I'm going to combine my like terms. So on this side, I have 21x squared, and then I combine my like terms to make negative 41x plus 10, and that's all over 7x minus 2 times 4x plus 3. That's the first side. So now on the other side, I'm going to do another box because I need to multiply the other top pieces. So I need to multiply negative 2x and 1 and 4x plus 3. So negative 2x and 1 and then 4x and 3. So that's going to give me negative 8x squared, 4x, negative 6x, and positive 3. And combine my like terms. So for this one, we're going to be adding. So we have negative 8x squared, negative 2x plus 3. And that's all over 7x minus 2, and then 4x plus 3. And now, all I have to do is combine my like terms for the numerator. So I have 21x squared and negative 8x squared. So that's going to give me, so what do we have? 21 minus 8. So that's technically taking away 1. So 13x squared. All right, then we're going to have negative 41x and negative 2x. So that's going to give me negative 43x. And then finally, we have 10 and 3, which is going to give me 13. So that's going to give me that A value, that B value, and that C value. So A is 13, B is negative 43, and C is 13. All right, so I hope this helps. If you need or have any questions, just email me and let me know what I can do to help you.